Welcome to another episode of WebSphere and Liberty Community Spotlight. The topic for today is running Liberty in containers. My name is Christy Jesuraj. I'm a developer advocate and a team lead. I mainly work with these WebSphere Liberty containers and operators. Joining me is Arthur de Magalhaes. He's the master inventor, STSM, and also the AI Ops integration architect.
Hello.
Hey, Arthur. So as for the agenda, so we'll be talking about the certified Liberty images that you can use to build your application images, some of the best practices to follow while doing that, and then we'll have a demo at the end to cover the various topics. If you're not familiar with containers, don't worry. As we go along, we will cover some of the basics. So let's get started. So I'll pass on to Arthur.
All right, thanks, Leo. All right, so hey everyone. So we're gonna start talking about the operating system layer of the container. As you see, when you're working with Liberty images, there's really three main layers. There's the operating system, there's the Java layer, and there's the layer that has the application server itself, so the Liberty version. And the operating system is often one of the things that you have to look at first, because that's the base that's gonna kind of give your container all the capabilities that it needs and have the securities and things at the root level. So the one that we recommend the most, as you see in the tags that we have, is this one called Universal Base Image Operating System. It's from Red Hat, short UBI. So you're gonna hear us talking a lot about UBI, and that's what it means, Universal Base Image. And think about it as the next version of Red Hat Enterprise Linux, so RHEL. And the difference there is that the restriction has been lifted in terms of being able to push that operating system into external registries that are available to everyone. With RHEL, you had the issue where if you build a container or an image with RHEL, you had to keep it into a registry that checked if somebody had entitlement to RHEL. That was a restriction of the license. With UBI, you can push that into any public registry, like Docker Hub account, your own personal account. You can push UBI images there. So that's a really cool thing in terms of opening up the ecosystem and getting a lot more developers and folks being able to use this kind of enterprise level operating system in their container and not have to do development with one operating system, and then once you switch to production, now you're using a different one, and a lot of things can go wrong, and you're not really testing with the same one, which defeats the purposes of using container and images in the first place. So RHEL, UBI is really bringing everything that RHEL had in terms of the enterprise capabilities, the life cycle, the security, the patching and all that, but opening up now to the community, right? So that's really the advantages of using UBI. So the next slide, we're going to talk about the different flavors of the Liberty images that we make available. So us from IBM, we push out images to two registries, the Docker Hub registry and the IBM Cloud Container Registry. So in both, you're going to find these images that we're going to talk about throughout the presentation. You can pick which one you're more comfortable with, or if some people have preference in terms of trusting more something like IBM Cloud Container Registry, but Docker Hub's still the most popular registry. So your mileage may vary in terms of where you want to fetch your images from, but they both come from us, so they both have the same code and quality. One of the things we did was really try to simplify which tags you have. We have available for you. Previously, we had kind of fine-grained tags that went into specifics like the Java EE version that you wanted and microprofile, and we simplified that to really take advantage of Liberty's ability to expand its set of features. So basically, you start by choosing what stack do you want, meaning what operating system and Java layer do you want on top of or below Liberty. And you see here on the page a few of the different flavors. We're always looking to integrate new ones. So for example, temporarily, we always have the short-term release version of the newest Adopt OpenJDK. And of course, the long-term ones as well. So you can see here, you can kind of mix and match with UBI with IBM Java, UBI with Adopt OpenJDK, and you can pick 8 or 11. There's flavors with Ubuntu as well. In the cases where you want to deploy into a, for example, Kubernetes environment that is not OpenShift, then Ubuntu would be a good solution for you to get support for that operating system. But if you're deploying to places like OpenShift, UBI is the one you want to go with, and the one we recommend. So in terms of tags, once you pick this kind of matrix of stack, is you really, as a developer, you probably will start with full. Full means it has all the features available. So if you're just doing some development, like, hey, I saw this cool OpenLiberty sample, I just want to run it, you probably just pick the tag that has full, has all the features. So you don't have to really worry about downloading the features or having connectivity or wait for those features to be downloaded. You just have full image, which is much bigger, but you get the convenience of not having to download anything. But for anything more serious than just doing development in your laptop, so when you start moving to QA, closer to production, you really want to start with the kernel's lim tag. For OpenLiberty, for WebSphere Liberty, would be the kernel tag. And what that means is that you start with the minimum core of Liberty, basically. So the smallest amount of Liberty you can have. And based on your server.xml and the features that are called from server.xml, the container, the image will grow to just have those features. So you do so by calling a set of scripts that are built into the image. So Leo will later on show an example of a Docker file that calls those. But it's a really good way to kind of right size your container to your application needs. Let's say you have 100 applications. They're each going to be different because they each need different features. So just like Liberty outside of a container, where you use this pattern of starting with kernel and building the Lego blocks of features, same pattern in the container world, where you start with a very minimum base image and you grow that to just have the capabilities that your application needs. So your container is as small as possible, which is definitely one of the number one goals that people have. All right, so go to the next slide. So this talk is based on Liberty containers, but we thought we would mention that there is also a WAS-based container. The reason you may want to go to that is, let's say you ran a tool like Transformation Advisor and you got a few hits that weren't in the easy category. They were like in medium or complex, meaning you may have some dependencies on WAS in the APIs or just WAS itself. And you're not ready to change the source code. Maybe you don't have developers that are confident with that code. It was written a long time ago. Maybe you just don't have the resources to refactor that app in terms of the code, but you want to run that application in the same environment of your more modernized apps, so in a Kubernetes environment. So that's what we call this as a operational modernization, where you take an existing app running WAS-ND, you put it in a WAS-based container, and you run in Kubernetes. So Kubernetes is now doing the orchestration and deployment of that container, no longer ND, but your code is still running in a WAS environment, right? So you get a much bigger container in terms of size, but you do get the advantage of not having to refactor your application code in most cases, right? So we try to keep that balance, but the goal should always be to eventually move that to Liberty, because you get not just the footprint advantage, but the startup and just the flexibility and the new set of APIs, like the microprofile APIs that Leo will mention, they're available in Liberty. So it's look at it as a stepping stone before you get your ultimate goal, which is moving your applications all the way to Liberty, which fulfills that application modernization, where it's not just the edges, but the actual code as well has been modernized. All right. So when we talk to customers about what is the guidance that we have, it's very important to note that the images that we publish in the registries, those have, like I said, the operating system, Java, and Liberty. You need to add your applications into it. But for an enterprise, there's even a step before that, where you want to produce these things that we call enterprise-based images. And what that is basically starting with one of the certified images that we have in one of the registries that you've chosen, and customizing that to your enterprise. And customization can mean a lot of things. It could be running a set of yum commands to customize the libraries that you have in your operating system. It could be some Java tuning. It could be, in most cases, some default configuration in Liberty. And you can create then different enterprise-based images. For example, you can have one that's for things that are going to be kind of user-facing, like a web UI kind of enterprise-based image. So maybe it has different security artifacts built on. You may have a different one for, depending on the type of backend, if you have one that does a lot of processing. So depending on the types of kind of templates that you want to set for your enterprise, you can create many of these enterprise-based images. And that's something you would keep in-house in your own internal registry. That could be any internal registry you have. It could be the OpenShift registry for if you're running an OpenShift, for example. But there is that step of kind of curating the image that we publish into something that has a lot of value add or a lot of consistency for your enterprise. One big advantage of having that is that, like we said, if you have 100 or 1,000 apps, if they're all using the same kind of enterprise-based image, that means they have the same layer. So coming from, in the picture on the right side, if you start from the bottom up, you have the operating system, the Java layer, the runtime framework, which is Liberty, and then the set of libraries in common configuration that all these apps would share, or the apps within a certain group of your enterprise-based image. And this really pays off when you are transferring these things between registries, because the way that the container images work, it's based on layering. So if you have the same layers already in the target registry, you don't have to transfer those layers. You just transfer the delta, which would be like your application and configuration. So you get a big advantage in terms of the performance of deploying these things into environments where another enterprise-based image has been deployed. All right, so that's the pattern that you should use. And before I pass it over to Leo, just to recap that after you have this enterprise-based image, there's always the step of having a Docker file that adds your application and your configuration. You don't do that at runtime. I know that there's been a lot of misconception in the early days that you would deploy the image that we have, or even your enterprise-based image, and then you do something like volume mount your app and your config. That works, but is really not robust, and it kind of goes against the best practices that we have. So just throwing it out there that you always have that extra layer that you add on top. So I believe now, Leo, you're going to take us through the best practices for containers.
All right. Yeah. Thanks, Arthur. All right. Yeah. So some of the programming models that are available when it comes to creating your application that will be running in a container. For example, in the case of like Java applications, there is the Eclipse microprofile. So Arthur touched based on the configuration, because once you build this application image, you will be running in many different environments, and you don't want to hard code any environment-specific values within your application image. If you do, then you'll have to rebuild for each environment. You want to be able to separate that configuration so you can dynamically inject that as the container is running. So there is the microprofile config that's available that allows you to do just that. The health check is related to the orchestration of these containers. You will not just have one container, you will have many different containers, many instances for each of the application as well. So these containers will be managed something like Kubernetes. So it's very important to have that health definition, so these orchestrators can look into the health and state of the application and take the necessary action. For example, if the application is not able to handle traffic, it can stop sending the traffic, or it can restart the container, hoping that will address any issues. Then there are also the metrics and for any performance related. You can gather performance-related information and optimize your application as it's running. And the other one is the microprofile open API, which allows you to find the different API endpoints that are available for you to consume, as well as advertise your own APIs to others. All right. So as you are developing this your application to run in a container, it's very important to consider these aspects, especially the configuration and the health check. So that basically bridges the gap between the container and the environment where it's running. Right? Yeah, so another best practices to consider is the container immutability. So as Arthur mentioned, if you worked with like virtual machines, working with containers might be a bit different because with the VM you deploy the instance, then you configure that. It's a bit it's different when it comes to containers. You want to do all that configuration except for the environment specific aspect of it. For example, hostname would be different per environment. You want to be able to inject that. But anything else in terms of the configuration for the server, all that should be built as part of the image. So you don't deploy the image and then as it's running, you don't want to mutate that, because if the container were to go down, all those manual changes would be lost. So you want to be able to, you should always avoid that. And some of the other best practices is our Liberty images, they run as non-root for security reasons, of course. Especially that's a requirement in OpenShift. So each of the containers is running as non-root random users. So even though that provides the security that is desired, it comes with a set of permissions that you need to look out for. So as you are adding your artifacts into the image, you would see you would need to do something like as you're copying, you might see like user and the group ID like this one. I'll show some examples later on, but this is done on purpose because as the container is running, it's running as non-root, and that non-root user should have the necessary permission to access these files. So you need to pay attention to the file permission as you're adding artifacts. Another best practice to consider is related to labels. So you should always use the appropriate labels. And instead of coming up with your own labels, you should always look for standardized labels that are, in this example, I have some from the Open Container Initiative. So they have like different labels. So you should always look for that and add them. So this not only helps to identify your containers as they are running in different environments. There may be some tools that have this capabilities that will be looking at these labels and provide like usage metrics or other things like that. So you should always label your images and always use the industry standard labels. Right. The most important one is this one. You should always pay attention to the instructions that you have within your Docker file as you're creating the application image. So as Arthur mentioned, each instruction in a Docker file is a layer. So as the image is being built, it's being built layer by layer. So unless that particular instance changes, the cache will be reused. So if you're rebuilding the image, it will be much faster if you write the Docker file in a way where the artifacts that are changing frequently is kept towards the end. Because if you put that at the beginning, then it will have to rebuild anything from that step onwards, right? Another thing to pay attention is what you are using at build time versus what your application needs at runtime. So for example, in this case, we have this single run instruction, but that's doing a lot of things. It might be hard to read, but this is done on purpose just to keep all of these set of instruction, all of these commands in one instruction. So for example, in this case, we are installing some libraries that are only needed at build time. We don't need them at runtime. For example, the unzip. So we are installing and uninstalling them in the same instruction. So as your image is built, it's like that that library never existed. If you were to do this in two different instructions, even though you remove that unzip library in a later step, the final image would be as big as that unzip library is still there because of the caching mechanism. All right. Another example would be any zip files that you extract. Once you extract that zip file, you would not need that. So you should always look to use and remove any artifacts that you would not need at runtime. So in this case, I'm showing an instruction from our Open Liberty certified image. This is the Liberty binary itself. We download that from the repository and extract it, but we once we do that, then we no longer need that zip, so we just remove that. All right. So once you have created your Docker file, then you need to build it in order to produce the application image. So you have a couple of choices when it comes to that. So you can use like legacy build systems. So you send the Docker file over, and that will actually build it. But the drawback with this one is you don't have much. You have a lot of control with exactly. You can specify what exactly you need, but then you will have the overhead of maintaining these legacy build system, and there may be conflicting like Java versions. One application may need one version versus the other one, so you have to worry about all that. So you have a lot of control, but then not so much convenience. On the other hand, if you are going with something like source to image, where imagine a scenario where as soon as the code is checked in, it will automatically kick the pipeline to produce the image. So it's a lot of convenience. Everything will happen automatically. But oftentimes, the image that gets produced, it will have artifacts that are not really needed at runtime. So it's bloated with things that are not really needed. So you'll be paying the footprint. So on this spectrum, you have the convenience, but not so much the control that you would desire. So for that purpose, we would recommend something in the middle called the multi-stage Docker file that might be provide the best of both worlds. So the multi-stage in this example is indicated by the two from statements or the instructions. So in the first stage, we are actually using the Maven to build the source code, and that will basically produce the binary that you would need, the application itself. And in the second stage, it actually points to that first stage and copies the artifacts over into the final image. So in this example, we are using that enterprise base image that Arthur talked about. So the nice thing about this one is you're keeping the source code and the build instruction, everything side by side. And the other thing is we talked about the instructions, the layering, and the caching mechanism. But if you are following this approach, you don't need to be as efficient in the first stages. You only need to be efficient in the last stage, because that's what actually produces the final image that you would be deploying. So you don't need to be as efficient in the previous stages. All right. So with that, let's go into demo. So at any time, if you have any questions, please feel free to put them in the chat, and we will try to get to them. Arthur, did you want to add anything before we go into demo?
No, I think you covered pretty well. Okay. I guess at the end we're gonna have some links for folks to try the stuff that you're doing. So yeah, look out for that.
Cool. All right, so let me switch over to the demo. So in this case, I have this two different Liberty applications. So I'll go through the process of like building them and running them locally, as well as in an OpenShift environment. So let's look at the artifacts that I have here. So I have a Docker file, a server configuration, as well as the application itself. So if you look at the server configuration, so it has a set of features, as well as the configuration for the HTTP endpoint, and then it points to the application. So it's a simple application. So what this application does is it basically goes and grabs the system properties where this application is running. All right. So this is again this is a sample app that's used in some of our Open Liberty guides. So I'll share the link at the end. That's where you can learn more about not only just containerizing images, but anything related to Open Liberty. We have a lot of guides that goes through the different topics. All right. So let's go ahead and build this application. So the command to do that would be docker build, and we will tag this one. Let's use the name of the application system, and the dot at the end indicates that we want to build the image using the Docker file in the current directory. Oh, sorry, before I do that, let me quickly show the Docker file. Right. So in this case, I'm not using an enterprise application image. I'm building directly from the Open Liberty certified images that we have. So in this case, I picked the kernel slim because I want to keep the final image small. And I went with the UBI and the Adopt Open JDK Java 8 version. And the version at the beginning indicates that I want this particular version of Liberty. But if you were to exclude this portion, then you would always get the latest available Liberty version in our repository. All right. Then I have some labels. So as we talked about the best practices, so I have some labels from the Open Container Initiative. Then I'm copying the server.xml into this particular location. Once we deploy the container, I'll go into the container and show the different locations that we have. Then we have this helper script as part of our image that basically grows this like bare minimum server with the features that your application would need. So that's what this script does. It goes into our Maven repository. It looks at the server configuration, determines what set of features are needed, and downloads them. Right. And the next step is actually copying the application itself. And then at the end, we have this configure.sh. So what this script does is it actually improves the startup time. So it warms up the server. So your application starts much faster. So it behind the scenes is using the Java caching technology. So the build time might be a bit longer if you were not to do this, but it significantly improves the startup time, which is what you want when you want to have these containers running in like multiple environments. So the runtime would be more important than the build time. So this would be a common pattern that you should follow when it comes to building your application images. It will be a bit different if you were to use the enterprise image. You would first do this step and produce that enterprise image, and then use that as the base. But the idea is you would point. You would add your server configuration, then use the features.sh if you're using the kernel slim to grow the image. Then you add your application, and then you call this configure.sh to improve the startup time. All right.
Hey, Leo, can I just add something?
Sure, yeah.
So I just want to reinforce the point that you made earlier in terms of running as non-root. So everybody probably saw the copy command that Leo had on the Docker file had this flag for using user 1001 and group 0. So this is a very important thing that you should be aware of, because in the earlier days of Docker and containers in general, everything was running as root, which was a security concern. That's why a lot of restrictions and kind of things were put into place. For example, in OpenShift, it runs as a random user ID with user group 0. So in the early days, people didn't have to know about what user is running this, because it's always root, and you could do everything within the container, and you didn't have to worry about it. For security reasons, we tightened that down. So when you start from one of the Liberty images, you're running with user 1001. We just picked that as the user, and group 0. So that's why when you copy artifacts into the container, you need to have that flag so that it's accessible when the container runs. When it actually becomes a container from an image to container, it's accessible. So if you were running a script that required, for example, root capabilities in your Docker file, you would have to temporarily do something like user root, do the script, and switch back to user 1001. There's not a lot of cases you do that, but you might find some cases where you start to customize your Docker file, and all of a sudden your Docker build fails because of that. The other thing that we see common pitfall is that you would create like a directory or push some files that didn't have this flag here 1001:0. So then in the runtime you couldn't access it. So those are the two common things that we see a lot of people get wrong the first time. So just wanted to point that out. The reason for that flag is for that.
Yeah, that's an important point. Yeah, if you were not to include this portion, then the file will be copied as the root. So only the root will have permission at runtime, and you will run into issues, of course. Yeah, thanks, Arthur. Yeah, so we talked about the basic pattern to follow when it comes to like creating an application image. So I quickly want to show this. So this is our GitHub page. So I'll have the link at the end of the slide for you to get to it. But this has a lot of information, like including the different images that we have. It links to the Docker Hub as well as the IBM Cloud Registry. So this is pointing to the UBI images. So you can find the available versions and the different tags that you are interested in. And we also have the beta images as well as the daily images. If you want to pick up those images earlier than the official release dates. Then we have this section on the building the application image, and in this case, I basically followed the similar pattern as in this case, but this has additional things, like for example, if you don't want to pull the features from Maven repository and you want to have your own repository, so you can do that. So we have some instruction here on how to set that up, and all you need to do is copy this features.properties with those settings. The other thing that we documented here is the process to apply any iFixes or the interim fixes. So you can place them in this particular location, and when you call the configure.sh, it will actually apply those iFixes. So in this case, I'm using the latest Liberty version, so I'm not doing that step, but that option is there. All right, so let's go ahead and build this application image. I'm just going to call this system and then load. So in this case, I already built the image earlier, so it's using the cache. So as you can see, it was much faster, but when you run it, this step might take a little bit of time. But again, going back to that layering and the caching mechanism, you should always pay attention to the instruction. So in your case, like most of the time, the application is what that will be changing frequently. So that's why in this example, we kept it at the end. But in your case, if it's different, then you should always try to keep the artifacts that are changing frequently towards the end. So you can reuse the cache as much as possible, and that will speed up the build time. All right. So in this case, I have this image build. So this is another command that you can always Docker history, and you can specify the name of the image. And this is quite useful if you're trying to keep the container image size small. You can see like what each of the instruction is contributing to that size. So it includes all the way from the base image. But in this case, you can see that this is where we added the server configuration. This is where we call this features.sh. So in this case, we are using three features from Liberty, but they have like their own dependencies. So they were pulled from the Maven artifactory, and this is the application itself. And then when we run the configure.sh, it actually produces some of the cache to speed up the startup time, and that actually increases the size a bit. So you can see if you're like using other libraries and things like that, then you can see quickly identify which instruction is adding a lot of increase in size, and then you can optimize them if that's possible. All right. So let's go ahead and run this application image that we created. So I'm specifying -D to run this container in the background. Then I'm specifying the port mapping. So the first information there is the port on my local machine, and the second is the port within the container. So I want to map to the same one. Then let's give a name for the container, so it's easy to reference it later, and then the name of the image. Right. Yeah, so the container has started. So if I were to do docker ps, you can see the container is up and running. So let's actually go into the container so we can see what's inside. Right. So right now I'm inside the container, and these are the different directories. So if you have worked with like Open Liberty runtime, whether in container or outside, you would be somewhat familiar with this structure. So we have this Liberty directory, and this is where you can find the server as well as the libraries and so on. There's the logs directory, so the messages.log, it goes in there, and then there's also the config directory. So in this case, you can see the server.xml that we copied. It was copied in here, and the application is in the apps directory, right? But yeah, you don't need to go into the container to see the logs, so you can run the docker logs command to get the logs. So in this case, you can see the server started, and each container gets its own like network, so it has its own host name and IP address. But as you can see, it's running at that 9080 port that's exposed by the container. All right. So let's go ahead and deploy this application. So in this case, I'm mapping the local port to the container port, so it's able to redirect the request. And this is actually coming from the container. All right. Just keeping an eye on the time here. All right. That's one of the application. So the other application that we have here for the demo is the inventory. It basically builds a inventory of system properties, like from different systems. So it also has like similar server.xml. It has some additional features here, and the Docker file. It also follows a similar pattern to build the application image. So let's go ahead and build that. So if we list the containers that are running, yeah, let me start the container. So in this case, I'm using a different port to avoid conflict. So I want to run this application at 9081, but the port within the container is still the same. It's still 9080, and using the inventory as the name. Right, so now we should see both containers running, and you can see the port mapping. If I go to that endpoint, 9081. So right now we don't have any systems that are running. If I were to run the Docker logs inventory, this is running on a different host, but not the port. It also thinks that it's running at this port, even though it's not. So that's the abstraction provided by the container. You are able to run both applications side by side. All right, so let's go ahead and add that system properties. So I'm grabbing the host name of the first application and going to specify that here. So that's basically going to add that system properties into the inventory. So now if I go back to the systems, now we see that system is listed here. All right, so that's the local, so how you can run applications side by side in your local environment, how to start them, how to go into the container and see them. Stopping the container is pretty easy. So that's the docker stop command, and you provide the name of the container. So even after you stop the container, it would still be listed under the stopped containers. So as you can see, this one, the system, it has stopped, but it's still being listed. But if you want to remove the container altogether, then you can use the rm command, docker remove. Right? Then you can also use this shortcut to stop any containers that's running locally. So you specify the same docker stop, but then you can query all the running containers and get their ID using this command. And this way, you can like stop multiple containers at the same time, right? And you can do the same thing for removing as well, all right? So now if I go and list the containers, including the stopped ones, we don't see anything that's running, all right? All right, so that's how you build and stop and the containers locally. But often, like in like production environment, you would have this container pushed to a image registry. So I'm going to demonstrate how to do that. So in this case, I'm using an OpenShift environment that I have set up here. Grant the password. So this is a little bit of sneak preview into one of the upcoming topic that we will have on how to like orchestrate containers. But we just want to quickly show how to push the image to another registry and how you can deploy them in a Kubernetes environment. But we will deep dive into this in a different session, right? So to build the image, I mean, we already built it, so we just need to tag it and push it into this registry. So in this case, this is where the registry is. So this registry is provided by OpenShift, and it's exposed via a route, so it's accessible through that. So the only requirement to push that is when we are actually tagging the image. We should use that as part of the image name. So let's go and see what we are doing here is we are using the docker tag command. We already have this, we already built this system image. So we're going to tag that, but with a different name. So we are using the host name, and this is the namespace where the image to push to, and we are specifying the name of the image. And in this case, we are also specifying the tag 100 corresponding to the application version. All right, so we tag that, and in order to push it, we use the same docker push with the name of the image we tagged. All right. So in this case, I already pushed it, so it was a much faster. But if we go back to the image stream in OpenShift, this image was just pushed in here, right? So let's do the same thing for the other application, tagging it. This one I didn't push before, but it should reuse some of the cache. So as you can see, it's only pushing the artifacts that are specific to this application, but it's reusing like the Open Liberty application image and everything from already pushed image, which is the system. All right. So now if we go back, we should see both images are in the image registry. So let's go ahead and deploy them to the cluster. All right. So that's where the Open Liberty operator comes in. Again, this is a topic that we will deep dive into another session. But this basically allows you to deploy your application in a Kubernetes environment, such as OpenShift, and manage them. So in this case, I'm going to create an Open Liberty application resource. I'm going to point to the image that we just created, system 1.0.0. Here I'm specifying that I only want one instance of this application. You can have multiple if you like. And this is basically exposing the application, so it creates like a proxy or ingress, so the application can be accessible from outside the cluster. All right, so let's go ahead and deploy this. So that one was deployed. So if I go to the route and click on this, yeah, so this is the welcome page of the application. And if I go to the system properties, the same endpoint, then we get similar output with all the various system properties for this container. So yeah, so this is similar to what we had before, but the container was running locally, but now it's running in the cluster. All right. So we can do something similarly quickly for the other application as well, for the inventory. So it's using it's pointing to the image that we pushed earlier to the internal image registry in OpenShift. And we are going to deploy that. Then if we go here, systems. Not sure what happened, but try it again. All right, the application ran. Maybe I made a mistake when I specified the image name. Okay. Anyways, we are running out of time, but as you can see, the step is pretty similar. The way you push the image, and then you just deploy that using the Open Liberty operator.
This is a good example when things go wrong. There's a nice error, right? Like the image pull error. Pretty self-descriptive that, hey, we couldn't pull that image. So then you kind of check if you had the right name and tag. So.
Yeah, we can probably deep dive into that in the next session on how to troubleshoot these things. But we just wanted to quickly give you like a sneak peek into the container orchestration, because that's another topic that we will cover in the future. But yeah, as we demonstrated, that's how you push the image, and then Yeah, we will share the necessary links for all the different topics that we talked about. So let me go back to the slide. Yeah, so here I have included the links to our GitHub repositories with the Open Liberty as well as the WebSphere Liberty images. And we also talked about the WebSphere traditional image and as well as the Open Liberty operator if you are interested to check that out. And we also have a bunch of other links here that's pointing to like creating an application with Open Liberty, like creating your microservices and some topics on modernization and so on. And as I mentioned earlier, the various guides that we have for Open Liberty. So each of these guides, they are like 20 to 30 minutes long, and you can spend that much amount of time and quickly learn about a particular topic. So would highly encourage you to check them out. All right. So that's all in terms of the presentation. I don't see any questions in the chat. Are there any closing remarks?
No, just, yeah, we're looking forward to hearing back feedback. So hit one of those links for the GitHub community, and you can open issues and chat with us. We love getting feedback.
Right. Yeah, that's an important point. Yeah. Yeah. So this is a public GitHub repository. You can check out the resources that we have, as well as if you have any specific requirements, please feel free to open issues, and we are always monitoring, and we can continue the discussion there.